Okay, so today is really about conversions. Conversions. It's all about conversion. This is a big part of the course for the people who are thinking about being nurses, because conversions are kind of a central part of the math that nurses need to be confident about. Brings up a lot of questions about not only how do you do something, but how do you get to a point where you feel really good about it. And I think that's something that can apply to all of us as we think about stuff. So the basic process for conversions is going to be a fraction conversion method. And I've set up kind of a template here. And before I jump into that, I'll just say a little bit about fraction operations. The good news is that we don't have to get deep into fraction operations in terms of the expectations. We're not adding fractions, not subtracting fractions. I mean, I'm not saying that those things aren't fun to do, but they're not a big part of this course. But let's just talk quickly about the basic mathematics of multiplying fractions. Do you guys remember how to do that? If I do 3/4 times 10/11ths, how do I accomplish that?
Multiply across.
Straight across. So what I love about multiplying fractions is it's kind of the way you wish everything was with fractions. Addition and subtraction turn out to be a little complicated with common denominators and whatever. Again, we're not doing that. Don't worry about it. We're just multiplying across. Now, just to return to something from the very early part of the course, can 30/44 be simplified? Remember what I mean by that? Yeah, what do we do to simplify it?
Find the common factor.
Okay, and what can I divide both of those numbers by?
4.
Not evenly.
Not even.
2.
2 is the biggest one, yeah. So I can divide both of those by 2, and that leads me to a simpler answer, which is 15/20 seconds. Okay, there's nothing better about 15/20 seconds compared to 30/44, except that it's smaller. And in this case, I don't know whether it makes that much of a difference. I would argue that if you're talking about 49/98, people are not going to respond to that as nicely as if you just said 1/2. So that's my argument for simplifying things, right? Sometimes simplifying it makes it easier to understand. But I want to bring up a little point about the process of multiplying before we get into this conversion section, which is that there is an opportunity ahead of time to do the simplification up front. And that's where we see the 10 and the 4, and we're like, okay, well, we can divide this by 2, and we can divide this by 2. And so that just kind of gets us to the simplified answer a little faster. Now, how we're going to apply that is, let me just give you a different problem here. We're going to have something that looks like 3/7 times 7/11, and then we're going to say, oh, this thing can be crossed out, and this thing can be crossed out, and therefore the answer would be go ahead.
3/11.
3/11, right.
Okay, I got a question though. So it got to be like diagonal or across?
Well, it can be straight up and down as well.
Could you close my door too? Because I just don't want to hear y'all.
Because the way we're going to see it is we're going to see it diagonally. But no, mathematically, it could be anything on the top with anything on the bottom. Okay. So that's really all I need to say about fractions to set the stage. We're going to multiply across, and we're going to have these opportunities where there's going to be something on the top and the bottom that can be crossed out, and we're going to utilize that. Okay, so let's go and let's take a look at a problem. Now, as we're going through this, I recommend you have your yellow sheet with you, because the first page of that yellow sheet has...
What page is this?
Well, it should be colored, so you should be able to easily identify it in your book, but according to mine, it's somewhere around 235. It's in the middle of your book because the first part is the course, and then the second part is like a supplemental set of exercises for a co-requisite course. But this page has all of the conversions that you would be asked to use in the course. Now, I should point out that Google, any search engine, and you type in conversion, is going to actually bring up some pretty nice conversion things. And I can easily imagine a situation in the real world where you want to do a conversion, you go to Google to do it. But our job here is to learn how to do it by hand using these units. Okay, so I think this starts on page 157, something like that. 150. I was off by 1 or 2 numbers. And I actually gave you similar problems, so I'm not going to start with their 6-week questions. I want to go back to our warm-up questions. We had a couple of warm-up questions about time. So the first question was, how long until the final? Is that right? I can't remember if those were the exact words or not. I guess I could look at the announcement. How many days until your final exam? Okay. I mean, I would say that these two questions are very similar. The only difference is that this one is specifying the kind of unit that we want. I'm going to use this word over and over again, and we've already used it quite a bit in the course, but let's just remember what a unit is. The unit is the word that describes how we are counting or measuring. And it's pretty important. This is kind of the interaction between qualitative and quantitative. I mean, there are very few times when we can just say a number and the context tells us enough about what we're saying that we understand what the unit is. But numbers have units in the real world, because whenever we talk about something, we are counting or measuring, and so there's some unit of measure that needs to go along with that. And that's really what conversions are all about, is the idea that sometimes we need to go between different ways of counting. So we're using time as a starting place because everybody has experience with time. So how many days until the final exam?
2 weeks.
Okay, which is more, that would be an answer to the first question, right? But the answer, how many days until the final exam, would be
14.
14, right? Right, so again, just to be clear about what I mean, 14, you can imagine being an answer to this question. Somebody, you say, how many days? And they say 14. When we say 14, then what we mean is 14 days. You got the number part and you got the unit part, right? Number, unit. This is just a different way of saying the same thing, right? It's technically not correct as the answer to the second question, but of course, if we're not in the middle of a math test, then who cares whether you say 2 weeks or 14 days? Everybody understands that 2 weeks is 14 days. It's the same thing, right? Now, the next question, I'm breaking it into an hours. So I say, how many hours until your project is due? Now, I hope that you started to move away from counting and thinking about how to use math to try to answer this question. So what was your thought about how to answer this question? I mean, here we are, 12:30 on Wednesday, or whenever you did the problem. So of course we could all have different answers based on when we did this problem. Let's just say noon on Wednesday. until when?
August 1st.
July, was it 15th until when on August 1st?
11:59.
PM?
Mm-hmm.
Okay. So we'll say midnight, August 1st. So what I'm saying about counting is I hope you're not saying, 1, 2, 3, 4, 5, 6. How are we going to answer this question without just counting all the hours between noon on Wednesday, July 15th until midnight on August 1st?
Well, first you got to find out how many minutes are in an hour, then multiply by how many days you need. Right?
I don't know that the minutes have anything to do with it. We don't want to make it more complicated than we need to. Did you mean hours in a day?
There's, for example, 24 hours in a day.
That's true. So how do we use that to help us
Then
move forward?
multiply how many days.
Okay, so how many days is that?
So 24 times what, 15?
14 days.
We got a 15, we got a 14, right? That's going to make a difference whether we choose to do 14 or 15.
I don't know, like, if this month ends on the 31st or 30th. I don't know.
Okay.
It could even be 16 days.
Could be 16. Right? So if we're trying to get the answer right, obviously that matters. How many whole days do we have? But this essentially is a conversion, right? These are all conversions of days to hours. What we do is we just multiply how many days by 24, and that gives us how many hours, right? And in its simplest form, a conversion is just multiplication or division. There are conversions like the temperature conversions where there's actually a complicated formula, not crazy complicated, but it's more than just multiplication and division. But for all the conversions that we're going to do, it's just going to be essentially multiplication or division. So I think August 1st is actually Saturday. Correct me if I'm wrong. And so I would just use my kind of mental calendar. Basically, I've got Thursday, I've got Friday, and I've got Saturday. And then I have a full 2 weeks beyond that. So I actually think it would end up being 17 and a half days of hours that you have before your project is due. If you disagree with that, we can fight about it after class. So you got 420 hours of time that you could do stuff on your projects. It's a lot of hours. Please do not leave it until the last 24 hours and then get serious. Do a little bit of work along the way. Okay, then the last question was how many working minutes do you have available to you? Blah, 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 blah. So, and then I tried to define working minutes so that we would all have kind of a common definition of it. The point is that not every single minute of the day is available to you. If it were, I would just take 420 and multiply by what? If every single minute of every day was available to me.
About 17 and a half.
Well, 420 is already 17.5 times 24. I just want to know how to change hours into minutes.
About 60.
Multiply by 60, right? Right. So this is kind of my maximum. Not possible unless you are a robot or a computer to put in that many minutes between now and, when your projects are due. And so that's another exercise, and I don't want to spend lots of time on this, but, as you're getting down to the crunch time of something, you do want to kind of not maybe spend 10 minutes and think about, all right, here's what I got left. It's 2 weeks. Where am I going to fit the time in? When can I squeeze it in? What else can I kind of cut out? Maybe I got to take a day off of work, or cut a few hours off a shift, or stay up a little bit later, or whatever. I mean, we're into crunch time. What kinds of decisions do you have to make to prioritize finishing the course in the way you want? You've invested a lot of time already. You want to finish out strong and get the grade that you need. What do you need to do that? How is it going to happen? So that's just kind of planning ahead and thinking about what's available to you. In a normal day, you know, how many minutes do you have available to work on math? It really depends on you. Could be as few as 120 minutes. It could be as few as 60 minutes. I've known students whose lives are so busy that squeezing in 30 minutes here, 60 minutes there is really an accomplishment. So, you know, and maybe it depends on the day, because if you're working a double and you got other stuff, then maybe there's really not any time for math that day. Is it 60% of the time? Is it 50%? Is it 40%? Is it 30%? Let's say you could get 30% of your life dedicated to math. Then you'd be talking about 7,000 minutes. Now, I hope that sounds like a lot, because we're talking about thousands of something, right? But obviously a minute is a smaller unit of time than an hour or a day. So it just sounds bigger because we're just counting in smaller increments. So I want to talk about time because it serves two purposes. One, just thinking about the timing as the course ends, and two, introduces us to the basic concept of conversions. So on the next page, it introduces you to an identity ratio that you probably are not familiar with unless you've worked with horses before. The concept here is that a hand is the same as 4 inches. So what is an identity ratio? Well, if you look at the previous page, it shows you identity ratios for time. An identity ratio is the concept that if I put a unit on the top and the bottom with the correct numbers associated with those units, then I make something that's equal to 1. So for instance, 7 days is the same as 1 week. So 7 days over a week is equal to 1 technically, because it's the same thing. And something divided by itself, 5 divided by 5, 10 divided by 10, that's equal to 1. So that's why this is called an identity ratio. And the fact that there's 2 of them is just a reflection of I can write this ratio 2 different ways. So here's what we're going to do. We're going to take our identity ratio and we're going to make a choice. And here they do this in number 2, where we're going to put the right unit in the right place so that, I'm going to bring out my red pen here, the unit can be crossed out. So I'm putting hands diagonally so that these can be crossed out. That leaves me with only the unit I want, because if you look at the question, it says, let's convert this to inches. So we're trying to convert hands, which is what we started with, over to inches. Now, I like the way they've set this up because it reinforces one of the things that I do, which is I get the units in place and then I put the numbers in place. So what numbers go in front of inches and hands in this fraction? You see how they've left space here because we still need to get the numbers in to complete this.
1 is inches.
Careful. Go back to the equality and look.
4.
There you go. Right? So when you're thinking about what number goes in front, just go back to the equality and make sure you get the number in front of the right word. 4 inches, 1 hand. Okay. So hands crosses out hands. At this point, I'm done thinking about the words and I can focus just on the numbers. When I multiply fractions, I multiply across. So 4 times this and 1 times 1. I know the bottom is 1. I think the top is, well, somebody can do it for me. What's 4 times 20.6875?
82.75.
82.75?
Yeah.
Wish I'd brought my little pen with me today. This is terrible. I'm going to stop doing this by hand. Okay. So that's, in a nutshell, that's the process. Let's practice. I'm going to go back to well, here, there's a formula sheet. There's these are some conversions. This is what you would find at the top of your formula sheet. You're welcome to follow along in the book, or you're welcome to just use your formula sheet. So let's say I need to do something like convert 50 ounces into pounds. So convert 50 ounces into pounds. So how does the process work? Well, the first thing I'm going to do is I'm going to put my thing I'm converting in the first fraction, so 50 ounces. The second thing I'm going to do, and I have this written down, I'll show it to you in a second, it as notes and steps, is I'm going to make it a fraction, so 50 ounces over 1. Okay. Then I need to get the conversion factor that's relevant to this conversion. So I have to go back to my formula sheet or the book where it has it. Here I can see this is the one that I should be paying attention to. A pound apparently is 16 ounces. So I go back here and I think about the fact that 1 pound equals 16 ounces. Which number is going to go where in order to get that diagonal cross out that I need? Am I going to put pounds over ounces or ounces over pounds? That's the decision I have to make.
Pounds over ounces.
Correct. Pounds on top, ounces on the bottom. Okay, once I put those in, then I'm going to put the numbers in. And again, I go right back to this and I put the numbers in front. 1 is in front of pounds and 16 is in front of ounces. At that point, I'm ready. Okay, I'm going to go ahead and do my little cross out here just because this was always my favorite part of it. Boom, boom. But I'm ready to multiply across. So what's going to be the number at the top?
50.
Right, because it's 50 times 1. There's also going to be a word there, which is pounds. On the bottom, I have 1 times 16. That's 16. I'm going to finish this process by dividing 50 by 16. And this is how many pounds 50 ounces is. Okay, now that might seem like overkill. If you knew by looking at the fact that a pound is 16 ounces that you were going to need to divide by 16, you were right. The reason that we do this approach, though, is because, number one, a lot of people don't know intuitively whether to multiply or divide. Number two, even if you think you know, when problems get more complicated, it's nice to have a structure that you can look at and say, okay, this is how I'm convincing myself that I'm doing the right thing. Because you can look back at the process and you can say, well, those are gone, and I've converted then ounces into pounds, and I've got what I'm looking for, and I've done it right. Whereas if you're just multiplying or dividing, you're kind of hoping that your instincts are right. That doesn't seem as good to me, especially in a nursing context when, you know, it may matter in terms of the medication that you're giving, the dosage that you give. Okay, so what I want to do now, I'm going to go ahead and pull up the notes here. I think it's good to try these 5 problems. And I'm going to share the notes that I just went through verbally so you can write them down if that's the kind of thing you like to do. For some people, the practice is more important than the notes, but here are the notes for that. I'm going to give you a few minutes to work on this, and of course, you're welcome to text me and say, here's my work. Am I doing it right? And this, to me, this is more important than at any other point in the course, because really the structure of setting it up is the whole purpose of this. So if I can't see it, it really impedes my ability to help you get it right. So I really encourage you to take a picture of a conversion process. If you're stuck, take a picture of where you are and send it to me so I can start giving you individual feedback.